Yeah. All right, so Alicia, you're here?
Yes, I'm here.
Mark you in. Angela. And you're at the bottom.
Yes, sir. Yes, sir, I'm here. Okay.
Let's see, who else have I missed? Mariela Barrios, are you here? No, Mariela. Ashley Martinez calls, she's not here. No, Jose Fucando. Brittany Hudson. Tiffany Lewis. No, Tiffany. Miss Moore.
I'm here.
Miss Moore, are you there? You did the problem incorrectly, I think.
Yeah, I figured.
So you get help from your fellow persons. You'll be good.
Okay.
But you are here. So is anybody else I missed that they think they were here?
Elizabeth Romero.
Elizabeth Romero. Yes, I got you. You're good. Thank you. Anybody else?
Did you get me? It's very staticky, so I really can't
Yeah,
hear.
Lizette.
Okay, thank you.
Yes, you are good.
Thank you.
I got your homework too. Did you hear that?
Yes, I did. Thank you.
What's the highest score that I said you guys could get on your homework?
I think it was 115.
I think you're right. All right, let's go.
No, it is 115.
You sure?
Yep, I wrote it down. I always write it down.
Gotta be careful what I say, huh? I guess if you have 4 children, you got to be careful what you say all the time, huh? All right.
They
You're
always
probably
remember
writing things
everything.
all over the place. Good enough. Okay. So let's go to this text now. I think I have it. Can you all see it now? Can you see the book? Thanks to Lizette.
Yes, we can see it.
So look, the inverse relationship is pretty good. In fact, tonight, I'm thinking, I don't know if we can do this, but I'm thinking we might do 3 sections. If we do 3 sections, it will make life easier for us because we have a night on Monday with 3 sections and we don't want to do that, although it's doable. Anyway, we'll see. So the inverse means you simply change the x with the y. That's all it means. Wherever you have the x, you have a y. And so it's pretty simple. So so the inverse of anything is the x becomes the y and the y becomes the x. So here we have a problem. Y equals x squared minus 5x. Find the inverse, we change the x and the y. And then we get y by itself. Now they don't finish it here, they just give you the solution x equals y squared minus 5y, but it's not finished. All they did was show you change the y at the x. They're just continuing to show that to you. Now, given this function, f of x, we know that's y, prove that it is a one-to-one function. that it has an inverse, that is. Well, let me share with you something that the book doesn't tell you, but hopefully this will be kind of meaningful to you. If I have a graph like this, the inverse of this graph is over here. So this equation has an inverse equation, which is this here. Now, if I draw this graph, it does not have an inverse because the inverse is part of it right here. That's what they're trying to say. Someone would have told me that. I think that would have been easier for me a long time ago. But so now they're going to do this. They simply put different letters in for it. And their explanation of it is that if you get A equals B, it is 1 to 1. That means it has an inverse. Now, x squared. That's the graph that I was just telling you. Let's go back to my method for showing you. Let's go to the calculator. Let's go to y equals, write x squared. And we'll graph it. Notice that this graph, like I described before, is equally on the left and right. So it does not have an inverse. And that's again what they're trying to share with you in this text. They're sharing with you that in number 4, x squared does not have an inverse. Second. This is Dr. Whitney. This is Dr. Okay. So a way to tell if something has an inverse function, if you look at a graph, is what we call the horizontal line test. If you draw a horizontal line, if it cuts through the graph one time, it has an inverse. If you look at B, it does not. C does, it only cuts through one time. D does not. And somewhere they'll tell you that it's not, doesn't have an inverse function. Now, determine whether the function f of x equals to is 1 to 1, or it has an inverse. So let me do this mechanically for you. The problem is given as f of x equals 2x minus 3. Again, this is so easy, you're going to say, why do we even teach these? And you'll say that after you see this problem. So we have f of x equals 2x minus 3. And they want to know what the inverse function is. We know that this is really saying y equals 2x minus 3, because f of x is really y. Now we're going to change the x and the y, because that's what you do in an inverse. You're going to get y by itself, so you're going to add 3 to both sides. Then you're going to divide by 2. Excuse me, over 2 equals y. Now, so if it is, you can see it does have an inverse function because it worked. It didn't end up with y squared. That's where it's no bueno. They end up with just y. So, but instead of saying y, we go f of x to the negative 1 equals x plus 3 all over 2. This means inverse. And they probably are going to write it like this. think that's the new method. So they just don't, this tells you it's an inverse. So let's go and see. I mean, we just did it manually. It was too simple. Now we're going to take a look at it. Okay. Yeah, they're right. Just like I said, f of -1 x equals x plus 3. So it does. It's just too simple. Now they want you to graph it. All you do is create a t-chart, or you can put it into your equation. You have there f of x -1 equals x plus 3 over 2. That means y equals x plus 3 over 2. Now, t-chart, you just can put in a number. You put in 0 for x, you get 3/2. I don't know if you can show it. You got to look at the. They don't do it for you on the -1. What they're showing you here in number 7 is the dotted line is nothing. That is a line of symmetry. The red line is when you graph the 2x minus 3. And then the inverse of it is x plus 3 over 2. So we can do that ourselves. We can do the same thing and graph it. Now, they give you a t-chart. You put 0 in for f of x, you get -3. Boom. The other one, I would have done the same thing. You put 0. They do it reverse, -3. All they're sharing with you is don't look at the right-hand yellow box. Only look at the left. Notice you have your x -1, 0, 2, 3, and you get what you get. Now, the inverse one is just switch them. You're going to have -5, -1, -3, 0, 1, 2, 3, 3. Across the 3, 3. Does that make sense to everyone?
Yes.
That's all it is. All you're doing is switching the x and y's and then regraphing it. Now, determine whether this function is 1-to-1. X cubed plus 2. Again, it's simple to do. You just change, just because it has a cube doesn't make it any harder. And you know that it's going to be because it's a cube and not a square. Squares are the ones that have those hold water, don't hold water. So let's look at 8. First of all, they're going to graph x cubed in the first one. X cubed plus 2. Then they give you the inverse, which is the cube root x minus 2. And there's your graphs right there. They're going to be the opposite. And you can put them in there. I don't want to go into the same more because it's just too simple. Change the x with the y. And the horizontal line test. Those are the two things you got to remember. Now, given that f of x equals 5x plus 5, use composition of function to show that the inverse is this. Well, again, you have f of x equals 5x plus 8. Let's get it. Give you this f of x equals 5x plus 8. We've already done this problem once. We said y equals 5x plus 8. We change the x and the y, so we have now x equals 5y plus 8. We want to get the y by itself. So we're going to have now x minus 8 equals 5y. Divide both sides by 5. X minus 8 all over 5 equals y. Then we have f of -1 of x. That's inverse equals x minus 8 over 5. All we do is switch the x, y, and got y by itself. X minus 8 over 5. Let's take a look. And there they have it in red, x minus 8 over 5. Now, restricting the domain. Let me give you my explanation again. It's just too simple. If I gave you this graph, x squared, and told you to graph it, you would get this. Boom. But what if I said the domain says x can only be positive? So that would mean all this would go away. So in this case, x squared, where the domain can only be positive, would have an inverse function. Why? Because you said you can only use positive x's. Now notice, if you put a -1 in the original equation, you get -1, then 1 up here. Boom. You put in a -2, you get -2, and then quattro, 4. So by saying that these can only be positive, you eliminated all this side. So that's why they have domain restricted functions, because that way you only get positive answers. That's what they're trying to say there. Now we'll go back to the book and see what they're saying. No, they don't even give you much of it. They don't really even tell you how, but that's what they're saying. Okay, so go on to the next one. What page would that be? Around 611 or 610? Does anybody know? The next section, which is supposed to be what, 8 point?
It's 9.3, 612. Page 612.
Thank you. All right. Graph the exponential function f of x equals x to the 0, or 2 to the x. And all you're doing is putting numbers in. I would go to my calculator. F of x is y. But you could do the same thing. You put in 1 for x, you get, if you put in 0 for x, you get 1. Notice that's the thing where this thing starts. 0, 1. And 1, 2, and so on. Now it doesn't go below the x-axis. It's symmetrical to the x-axis, or that's known as a horizontal line of symmetry. But again, to graph this, we sort of go to our calculator. As any problem you can do. Yep, y equals, come on. And what was it? X to the what power? Or was it 2 to the x?
Yes, today.
2 to the x. 2 to the x. Let's put that out underneath. Put that to work. There. I don't know if it's going to work. I don't like it. I hate to waste anybody's time. Just going to do it on a 2DX form. And hit graph. There you can see it, just like the book. It's going to work every time. If you don't believe what you see there, you can also go to your table. You'll see the answer 0, 1, 1, 2, and it's just too simple again. Let's look at the next one here. Number 2. Graph this one. 1/2 to the x. Notice the denominator gets bigger and bigger and bigger. it looks like this. And you can put this in your calculator again, and I'll just do this just because I want you to see how easy it is. The calculator can be such a good friend for math. You know how to use it. And we're going to go up to y equals again and get rid of this. And we're going to open our parentheses and put in 1/2. 1 divided by 2. And close the parentheses, and we're going to put this to the x power. And we're going to hit graph. Maria, are you still here? Maria Alvarado? Okay, guess not. So you can see this. You can see the line. There it is, just like the book. As it goes to the right, it gets smaller and smaller because the denominator gets bigger and bigger. All right, let's go to number 3. Graph each of the following, and before doing so, describe how the graph can be obtained from the graph of 2 to the x. Now, all they're doing here is this. If you look at the top, you have 2x initially, and then minus 2. And it wants you to see what happens to it. Well, the minus 2 moves it. It moves it. So if you had 2 to the 0, you would get 1. But in this case, you don't. You get 1/4. Why? Because if x is 0, well, in fact, it moves it. It moves it 2 spots. Now, 2x to the minus 4 moves it. Now, the x's up there is not affected. The minus 4 is. It moves it down 4 spots. This goes back. It says -4. So from the -1, which was the original graph, but what you see here in A is not the original graph. This is to the x minus 2. We'll see more about what happens. When you take x to the minus 4, it brings it down. Let's see if this is explained enough for you here for A. You know when 2 is to the -2, it has to cross the line, so it becomes 1/2, it becomes to the 4th power. So instead of 1, it goes down that amount. It shrinks it. And you can put any, well, it shows you there. It has a t-chart. It shows you what happens. 0, 1, 4, anything to the 1. So you get 2 to the 1. That gives you what? -1. So if you put 1 in for x, it's shown here, you get 1/2 because that would give you 2 to the -1. So it's 1/2. It's 1/2. If you put 2 in there for x, you get 2 minus 2 is 0. Anything to that power is 1. So you get 2 to the 1. And so on. And I made that too hard for you guys. And then -5, it just moves the thing up in another direction. In every one of these cases, if you don't know what the graph does, you should use your calculator, and sure enough, that's what you get. You should try C. Just so you feel comfortable. So you have 5 minus 2, the -x. So let's try that. And of course, that's y equals. That's how you know how to do this f of x. Stop it. And I'm getting wrapped around the axle too much here for you guys. But again, I want you to feel comfortable that your calculator can do anything. So we're going to clear this out. We're going to put in just what it said, 5 minus, that's this, 2, And then we're going to put x minus, excuse me, to the negative x. Yeah. I think that's right. 5 minus 2 to the negative. Mary, is that what is that what you had? Sherry?
Negative X.
Okay, let's see if that graphs out right. Exactamundo. Exactly like the book. It's so, calculator's making life so easy. And you see something like that on the test. Not really. Now, so they're going to give you a compound interest problem. I do not like to do these problems with this method. I think I taught this to the other group. I mean, I would love to teach you this using the other method. But should I? Well, look, here's what they do. They give you the formula. $100,000 is your principal. So that's your P. The interest rate is 6.5%. N is 2. You want to substitute these in over time. T stands for time. So if you put, what they did is they did the parenthesis first. 1 plus 0.065 over 2 gives you 1.0325. You may not believe that, but that's what it gives you. You would think it doesn't, but it does. Because you're taking the 0.065, half of that, and added it to the 1. Half of 0.065 is 325. So then you just put 0 in for T, 4 in for T, 8 in for T, and 10 in for T. And that tells you how much you're going to make. Now, I do not like this formula. I'd rather use my finance formula. I teach all finance problems that relate to money using that, because then students don't learn two different ways to do it. But this one is easy. Do you all understand what happened here? So if
Yes.
you put in, if you put in 0 for T, that means in no time you still get your money back, 100,000. At 6.5% interest, in 4 years, you'll make 29,000. Not too good, but not too bad. In today's, that's not bad. Now, the number E, Euler, what they call it that here, equals 2.7. Again, that's the most popular number other than pi. In most math circles, that is the most popular. So they simply want you to find the value, e to the third power. Meaning, I'll do, and e to the 0, anything to the 0 is 1. Let's just do a, e to the third power. Just so you can see where it's at in your calculator. Uh-oh. My calculator may have froze up. All right, in order for me to make this work, I'm going to have to get out. Don't go away. I'll be right back. Yeah, locked up. All right, hopefully you can see me. Hopefully we're back in business again. That thing does that every now and then, and I don't know why it does it. But let's see if we got all our stuff back. I think we do. I think we're going to take e to the third power. Can you guys still see my calculator?
Yes.
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 That, by the way, that's a record for me finding all that stuff and getting it back. Pretty quick. All right. So E is right here. Got to go to second. It's right above ln. We're going to put it to the third power. There's 3. Push it out and hit enter. Be at 20.085. Now, they showed you e to the 0. I'll just do that for the fun of it because it's always fun to see something to the 0 power. Everybody knows no matter what it is, it's going to give you 1. And there you go. So E is right here in the first row. Is actually the 6th button down. 7th button down. And it's the blue key above it. Lucky 7. Let's see that. I don't know if our book will be right. Sometimes it messes up. It won't. Yeah. What page were we on? Does anybody know?
6:15.
Is that what it was?
616.
Ah, yeah, thank you. I forgot the book doesn't reset right. So hopefully in a few seconds here, you'll see the book again. And there it is. Can you see it or not yet?
We can.
Yes.
Good. All right. Okay, so now graph e to the x, e to the negative x. Well, they're inverses. Boom. You can see them. We can put it in the calculator. We did e to the x, and e to the negative x. Would you guys want me to put this in the calculator so you can see it? Or is this good? No response? Okay, I guess you're good.
I think that's good.
It's just easy. All right, now, what they want you to see here is what happens again, the same thing. E to the x plus 3, you graph it. E to the negative switches the direction. And then this is another one here. All you have to do is, in graphing any of these, you can use a T-chart, but I would always use my calculator. So for, I mean, e to the negative 0.5x. Any one of these things you can do. Let's do it. We'll do B. Just to reinforce it, that it is so easy. So we're going to go up to y equals. I'm going to clear this out. And we're going to put in E. Boom. Well, it didn't go. My bad. I'm going to put in E. Got to go to second. There it is. And then we're going to put the negative 0.5. So negative is down here. It's not minus. It's negative 0.5. And it's an X. We're going to push it out. And we're going to hit graph. There you go. Exactly like the book. We didn't do anything different. Simply use our calculator. That's all we did. There it is, just like you see right there, B. The whole idea here is to know where E is and what happens when you graph with it. Let's move on. Let's do that one last one. I'm going to stretch you a little bit tonight, but in the long run, it'll make life better for us all. Let's go to 9.4. I think that's what we're on then, right?
Yes. A logarithm.
What page? Yeah, what page?
622.
Now, I'm going to do it like this because this is going to hurt your brain a little bit, logarithms. Now, graph x equals 2 to the y. Again, you put a number in for y, and then you can get the x. So if you make y 0, no matter what, x is 1, and so on. So all you're doing is putting numbers in for the y. If you put 2 in for y, we know that's 2 squared is 4, and so x is 2, and y is 2, and then x is 4. And you can see it there in the chart on the right. You can make y anything, you can work it in reverse. I work in reverse because it's easier, because then you're going to get perfect squares. If y is 3, you're going to get x is 8. You can see it. And then you can graph any one of those you want. Just put it in the calculator. And if you put in y to the x, just change out the x and the y, you know that you're going to get the inverse. Boom. Now, that is not quite what we need to see, though, for logs. Now, find each of the following logs. A, for example, if you read it, says log base 10 equals 10,000. That means log, or it says 10 to what power equals 10,000, and that's 4. D, on the other hand, is 9 to what power equals 3, and that should be 1/2, or the square root. E, 6 to what power equals 1? We know anything to the 0 power is 1, so E is 0. Now, those are things you just kind of learn. Not really part of the logarithm stuff. It's just that you know. We'll get into the rules here in a minute. Now, when you convert an equation into a log, notice A, for example. The number that is lower to the exponent is the base. It never changes. The two numbers that exchange places are the 16 and the 2, or the x. So you get log base 2 to 16 equals x. So, B, 10 to the negative 3 equals 0.001. Log base 10. Notice, just look at B, the question up here. Just look at B. The 10 does not change. The only thing that changes is the negative 3 and the 0.001. That's the only thing that changes. So you get log base 10 to 0.001 equals a negative 3, as in B. So if you, without making these confusing, the number that has the exponent doesn't change. That's your base. Going back to A, 2 to the 16 equals x. Log base 2 to the 16 equals x. Look at example 4. 2 to the 5th power equals 32. 2 to the 5th power equals 32. You're going to go in reverse. You're going from log to exponential form. Look at A. A to the 8th equals Q. A to the 8th equals Q. All you change is the Q and the 8 every time. T to the X equals N. If you can just get that in your brain, it's an easy thing. The base of the log stays the base. The numbers that change are the exponent and the answer. A is the perfect example of what's on the test. 2 to the 5th power equals 32. Well, they want us to do log on the calculator. Log, I mean, that's just a log number, but it's going to give us an answer. We're going to find log, and they want us to do 6, 4, 5, 7, 7, 8. We'll just go to our calculator. Boom. This is just an exercise in finding logs. I'll turn the calculator on again. Clear this out. Second quit. Clear now. And we want a log. So log is right here. Boom. They want us to put in 645. That didn't come out, did it? 645 778. And hit enter. And you get 5.812. So log is the 6 key down, 3, 4, 5, 6 key down, yep. And you can make anything you want. You can take log 1000. That'll be an interesting number to guess. 3. Now, how does that happen? Why? Well, it's 10 to what power equals 1,000. There it is, 10 to the 3rd power. Remember, it's not written, it's log base 10. So 10 to what power equals 1,000? Of course, it's 3. All they wanted you to do is find them on the calculator. Log -3. Huh. This is, it doesn't exist because you cannot have a negative log. In fact, you can't even have a 0 log. Now we can get 0 for an answer, but you cannot have log 0. It doesn't exist. So it'll give you an error in your calculator. Error. Doesn't exist. Let's go back. So all we're doing is finding these little spots in our calculator for that. And we learned that you cannot have 0 log. Cannot have a log 0. Okay, now, number 6, find each of the following natural logarithms on a calculator. Oh man, we're going to do all that. We know you can't have C. So what C says what? Does not exist. Log, we did the 6, 4, 5, 7, 8. We got a number. I mean, we don't need to do any more of these. Log 1, let's see what E says. It's going to equal 0 because anything to the 0 power is 1. Yeah, it's not log 0, it's log to the 1 gives you 0. It's a difference there. Can't have a 0 log. Oh, and this is important, ln over E. Anything over its ln and E are the same. So you're going to get 1. We need to show that. We do. So we're going to take ln divided by Euler I don't think we can. It's not going to let us do it. Okay. What if we put 1 there, I think? Nah, we don't want to do that. I'll mess you guys up. I don't want to do that. Okay. They simply tell you that. Ln to the 1 equals 0, Le equals 1. Therefore, everything over themselves is 1. We could have done it. Yeah, we could have done the 1. Okay. Change of base. Well, that's what we just got through doing. Log 5 to the 8 uses a common logarithm. First, we let a equals 10, b equals 5, and m equals 8. So find log 5 to the 8. If you use the base, each one being the same, the rule is wherever you do the top, you can do the bottom. So they simply write log 10 to the 8, which is the numerator, and log 5, 10 rather, to the 5th is the denominator. Notice this, the second number is always the numerator, that's the 8. The first number is always the denominator. If the bases are the same, log base 10, you can do that. You have to have the same basis. Let's look at 8 then. They made the base e. It's so simple, it's unreal. As long as the base is the same, the second number is the numerator, the bottom number is the denominator. See if we can do this. I don't know if we can. By the way, log E is the same thing as log naturel. So let's go work out there. So we're going to take log naturel, 8, divided by log naturel, 5, close up parentheses, and click enter, and there's your number. So log 8 divided by log 5, same number. Log naturel, log, they're all the same. Just wanted to prove it to you. So all they've done is change the base. To change the base, whatever one you want, you just simply make sure the second number is the numerator, the original base is the denominator. So if you want to graph log 5x, the equivalent is y equals log base 5x is equivalent to x equals 5 to y. Kept the base the same, 5. They changed it from log to exponential. So look at number 9 again. Change f of x in your brain to y. So you have y equals log 5 to the x. The brain might be getting hurt now, but look. If you have f of x equals log 5 to the x, we can change this to exponential form. Remember, f of x is y. Now, if we keep the base the same, 5, that's that, we simply have to change the x with the y. So this is 5 to the y, and x equals that. That's all they've done. Change the x and the y. The base always stays the same. It's the same thing. Oh, crap. Darn it. Oops. Well, heck. That's the second time that happened to me today. I had all my stuff here, and it just, boom, fell on the floor. I'm stretching out my papers more and more and more. Pretty soon, they're at the edge of the table, and then they fall off. What a goof. All right. Estrella left. She probably wasn't entertained by that. All right, we'll have to do one more check here as we close down. Let's see here. And there it is. X equals 5 to the y. I mean, it's so simple. I just change those things around. So we all here next. Graph ln x, g of x, y equals gx equals ln x. So g of x is the same thing as y. Let's see if we can do that. Ln x. Let's see if we can do it. Go for a calculator. Clear that. Log natural is here. We simply put in our x, close our parenthesis, and hit graph. There it is. I mean, it's just too simple. All we did was plug it in. Just because they're using different languages, different terminologies, everything is the same. And there was the graph we just did. You can graph all these. F of x, we'll just do 11a. Just show you again how simple it is. Remember, f of x is y. We're going to graph ln and put in x plus 3. You can put any of these things after it in your calculator. So we'll do a. You just have to practice how to use your calculator. Here, we're going to go to y equals again. We're going to clear that out. And I wrote down here, we were going to graph what? Was it? What did we write? ln what?
X plus 3.
I wrote that somewhere down. You said ln.
X plus 3.
Ah, yes, I find it right here. my here. Well, here's ln right there. Boom. We're going to put in x plus 3. Thank you. Keep me straight. And just hit graph. Ta-da. Now, let me share with you why this is so. We graphed ln x plus 3. Notice where this thing starts at -3, just almost there. 1, 2, 3. Why? Because you cannot have a zero or a negative log. So somewhere here it should show that. Let's go to the next page for A. You want to show that. Remember, you cannot have -3 in there. So it has a domain. The domain starts at, there it is, 2.99. Well, it doesn't show it exactly. But look at -3, it can't hit -3. That if you draw a vertical line at -3, this red mark will not pass -3. Again, why? Because you cannot have a negative log natural. If it was a -3, it's a 0, and you cannot have 0. But you can come real close to it. And so that -3 is what we call a vertical line of symmetry. Here's just a problem, walking speed. This is just a problem. You can put any number in this, and they just tell you what to do for P. They tell you to put in P. So anybody can see the general equation, as you can see, is 0.37 ln. You don't know what P is. They're going to give you P, or you got to put it in, plus 0.05. So that's the equation. Now, so now they say, okay, the average speed in Montana is 106.954. So you put that in on the left. And then you are in for, actually, it's the P. W of that means that's your variable. So where the P is, we put in the 2, and they give it to you, 2714.856. 106.954. Looks like they changed that to a decimal, but we can do that. We're just going to do the same thing they tell us to do. So let's see what I wrote down here. 37L 106.954. So we're going to take the same equation you see here, 0.37 ln. We're going to multiply it by 1.106.954. We're added that 0.5, and we're going to get 1.8. That's all we're going to do. This is just an application of it. And they give you the number to put in. So we're going to take 0.37 ln, boom, and our number is 106.954. We're going to close our parenthesis here. Then we're going to add what they just tell us, 0.05. So all we did was use our calculator, do exactly what they said. We get 1.7, which is 1.8 approximately. 1.78. 1.7, yeah. So take a look. Yeah, they rounded up to 1.8. So the average walking speed of people in Billings is about 1.8 feet per second. Boom. Then they change the number and they do it again and so on. And I'm not going to do any more because I know you guys are burnt out a little bit, but there's nothing more about it. I just say get familiar with your calculator. Let me look at who's still here. I know we lost some folks, but maybe we gained one or two. I just want to make sure I got everybody accounted for that was supposed to be here. And I do appreciate your patience, you guys. But it's a lot of stuff. So did Yulissa ever make it in here? Yulissa Alvarado? No? Naomi, she said she'd be here, but Naomi, are you here? Never came, okay. Giselle is here, okay. Marisol? No Marisol. No Ashley. No Isaiah Green. No Brittany. Tiffany. No Tiffany. Man, it's a tough. It's not good to miss any of these. Miss Gift, are you here? No Gift.
You got me right, Dr. Wickman, Alicia.
Alicia, let's see if I did.
I've been here, Dr. Wickman.
Yeah, I got
I don't.
you. You're good. You're good. Yeah, I got you. You and I talked a little bit ago. We talked about your 4 kids. Yeah, you're good. All right. Well, that's it for today. I appreciate your patience. Any questions?
Thank
from
you.
anyone?
No.
Thank you, Dr.
Good night, Dr.
Good
Wickman.
night.
Good night.
Good
You
night.
say
Dr. Whitman, did you got me?
You too.
Verdiana?
Yes.
Let me see if I do. I do now.